So let's review the coding challenge, JavaScript intermediate. I think, guys, is the first time we run a upper intermediate challenge, or at least is the first time we just play an upper intermediate challenge. So let's see how it went. As usual, let me select the mobile view. So that should help on the readability of the screen a bit, hopefully. So yeah, I hope, guys, you can see the screen. Let me refresh. Question number 1 was about searching. I think question number 1 is one of the easiest problems you can get on the intermediate training. I don't want to say that was a gift, but that was clearly easier than usual. Yeah, search. What are we expected to search here? Look, you could. Can anybody tell me how many arguments our search function receives? Correct. 2 arguments, Ian. We first of all get the sentence with some random text, and then we got a token, yeah, or search string. So the idea is to figure out in which index that search string is. So for instance, coding is the new literacy. So why that function should return 14? Because the new token is at index number 14, starting at 0, capital C, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then, as you can see, starting at index number 14, we get the new token. It goes without saying, based on this example, that we should perform a case insensitive search. So we should look after the case of we should ignore, let's say, the case of the tokens we want to find. So let me create a couple of arguments. First of all, let me call it sentence, and then I don't know, token or string or search, I don't know. Yeah, let me call it search token, for instance. Yeah. So in JavaScript, there is a very interesting method that works on strings, at least, called index of. Index of will give you the position of a string within a sentence. So for instance, if I go hello.index of E, can anybody tell me what will that expression return? 1. That's correct, yeah, because E is on index number 1. And what if I type L? That's correct, Adam. That will return 2 because the first instance of L is at index number 2. And what if I type ELO? That's correct, Adam. It's 1 because ELO starts at index number 1, ELLO. Yeah. So that's the way index of works. So technically speaking, we could do sentence.index of search token. However, can anybody see where the problem is? It's the case, that's correct, Minji. It's the case because if we run that piece of code, you see it's unable to return anything or to match anything. It just works on the last one because on the last one it doesn't, that token is not part of the sentence. That's why it works. But as soon as it should identify the location of the token, it doesn't work because you can see the algorithm is unable to compare different cases. So can anybody tell me how to solve the problem? To lowercase where? On the left or on the right? Sentence dot like that. The same thing. That's correct, Minji. So the idea is to normalize both tokens, both strings. Yeah, because we may have capital letters either on the sentence or on the search token. Yeah. So first of all, let's transform everything to lower cases, and then hopefully it will be much easier to run a search query. And then it works. Yeah, you can see it was as simple as that. If you find that expression slightly complicated, feel free to break it down in different lines like I did. So hopefully that will become slightly easier to read. Any question, guys? No? Cool, that was pretty simple, I believe. Let me check, let me read your code. So, search word index. So for instance, Adam, that's interesting. I like that. I like what Adam did. That's fairly readable. So he created two variables, lower sentence and lower string. Yeah, first things first, and then he does the comparison. Yeah, so that's pretty elegant. I like that. Ian, he is following the same approach. And you see, converting the string to, yeah, I may slightly complain about the readability of Ian's solution. The reason is he called the first argument a string, but does that mean that the second argument is not a string? That naming convention is a bit controversial because both are strings. You see what I mean, Ian? It's a bit hard to differentiate them. Also, let's talk about Ebrima. Cool. I've seen many developers using regular expressions. Obviously, I'm not against them. I think they are extremely powerful, and at some point they will be absolutely convenient. You just need to be careful, guys. I mean, using regular expressions is absolutely fine if you fully understand them. And I don't want to say that's not the case. I'm sure Ebrima fully understands that piece of code. Why I'm pointing to this problem? I've seen many times when dealing with unattended tests, with home exercises that candidates have done, that they return a test with some very complex regular expressions. And it goes without saying that in many cases, what the developers did, and once again, I'm not saying that's the case, but what in many cases developers did is just to copy and paste them from Stack Overflow, yeah? And that's dangerous. You remember the example I gave you about how to validate an email address on the last week or a couple of weeks ago, yeah? So please just use regular expressions if you fully control what they are doing, yeah? Because otherwise what you are doing is just creating a black box, creating an expression that you don't really control. Apart from that, Ebrima should use single quotes, yeah, instead of double quotes. What about Casey? Can anybody see any elegance warning for Casey? Sorry, for Casey, for Minji? Indentation, that's correct. That's correct. That's correct. Yeah, so string word. I mean, I will accept that to be called sentence or phrase or something like that, but string is a technical definition of the content of the variable. Yeah. So if you call it a string, then the second one, I don't know, should be substring or something like that. Yeah. Cool. That's pretty much it, guys. Anything else regarding the first question? No? Okay. Do you want me? Actually, I can do something. I can paste these answers on Slack. I mean, that was pretty simple, right? But probably one of the next questions will be way more complicated or spicy. So let me share it on Slack, so then you can play with it afterwards if you want. Cool. Let's jump to question number 2. Oh, puzzle pieces. That's interesting. That question was created by a former student called Farage, and that question is relatively tricky. So, wait a minute. I think there are more assertions at the bottom, right? There is some missing code. Let me refresh the page just in case. But I believe there were more examples at the bottom of this problem. So we have a function receiving two arrays, and the idea is we should determine, here you go, whether the result of adding all the pairs at the same index is the same. So for instance, 1 plus 4 is 5. Fantastic. So all the following pairs should, the result of adding all the following pairs should be 5 as well. For instance, 2 and 3, 2 plus 3, 5, correct. 3 plus 2, 5, correct. 4 plus 1, 5, correct. It all returns 5, that's why that returns true. However, on the third assertion, we got 1 plus minus 1, 0. That means all the following pairs should return 0. 2 plus minus 1 is 1, so that breaks the rule, so the function returns false. The problem is way more complicated to solve than the previous question, but let's go step by step. So I'm going to create the argument first, so list 1 and list 2, for instance. I'm not necessarily going to do something absolutely sexy. I will just first of all try to solve the problem, and then we'll see if there is a better way to solve it. Of course, at the end, I will compare with your approaches and try to find out some differences. So, first of all, the idea is we need to know how much every combination should return. So let me do something. Let me create a variable called expected, and I would like to sum the first two pairs. So the first two pairs will be list 1 on index 0, yeah, plus list 2 at index 0. Yeah. So whatever that returns, so for instance 1 plus 4, that should be what all the pairs should return. So now, and there are obviously multiple ways of solving the same problem, but I would like to show you how to deal with it using reduce, because as you know, reduce is a very powerful looping method in JavaScript. So I believe that the sooner you get used to it, the more powerful algorithms you'll be able to deal with. So my strategy will be to iterate over the first array. So list1.reduce. And then, can anybody tell me what arguments reduce receives? Okay. Yeah. Minji, say it again. The accumulator, okay, fair enough. And then what else? The value, okay, yeah, fair enough. Yeah, so the accumulator, you know, I'm not a big fan of referring to the accumulator as the accumulator, because that tells me nothing about the semantics of the exercise. What the hell accumulator means, yeah? Because of that, let me rename it. Instead of accumulator, let me call it, I don't know, are the same, or yeah, or matches. I don't know, to be honest. I don't know what's a good name. So what are we trying to achieve? We're trying to check if all the pairs add the same value, yeah? As the first, blah, 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 blah. Second element, return true if all the combinations add to the same number. So let me call it same number, for instance. So I'm going to, once again, iterate over the first list, and I will compare each number, let me rename instead of value number, each number in the first list against the same number on the element on the same index, or the number on the same index on the second list. So we need the default values, you know, using the accumulator. So let me assume that by default, the result is true. Yeah? By default, all the combination, all the pair add to the same value. So now, the idea is, I want to know if number, which belongs to list 1, plus something equal expected. Yeah, I want to check if every pair add the same. Oh, let me add return before I forget. If every pair return the same value, this value I expected here. So I got, imagine that we are on the first iteration. So number refers to the first element of the first array. But can anybody tell me how can I access the number at the same index on the second list? Yeah. Okay. Daniel. Adam. No, the number on the same index. So for instance, if I go list 1 equals 312 and list 2 equals 132, the first number is 3. So I want to access 1. Okay? Abs Absolutely, absolutely, Adam. You can pass a third argument called the index. So now, then what? Mm-hmm. Yep. So then what? Change the number to list 2. What do you think, guys? That looks good to me. What was that? Who was that? Was that Ian or Panos? Ebrima. Oh, cool. Hello, Ebrima. Good to hear you. Cool. Yeah. So Ebrima is right. Yeah. So we're going to compare the first number, or the. It's a bit complicated to explain. The number on the given index on the first list, for instance, number 3, against go to the second list and refer to the number on the same index. So 3 and 1, then will be 1 and 3, and then it will be 2 and 2. Will this work, guys? What do you think? All right, let's add the classic matrix. Iteration number 1. Can Minji tell me? Let me write down your name somewhere, otherwise I will miss some of you. So Minji, Adam, Ebrima, and then we got Daniel, Ian. I don't think Panos is connected. So Panos, if you are connected, please let me know. So Minji, can you tell me what's the default same number variable? That's correct. The default value is true. And now, Adam, can you tell me what's the first number? 3, correct. So then, Ebrima, can you tell me what's the value on list 2 index? Yep, correct. So fine, Dan, can you tell me what do we return after the first iteration? 3 equals 1. 3 plus 1. So you think we'll return 4? What do you think, guys? Why true? Correct. That's correct, guys. Dan, you missed the second part of the expression. So you did the calculation correctly. 3 plus 1. That's fine. But then what we return is not 3 plus 1. It's the result of comparing 3 plus 1 equal expected. Expected was 4. Yeah. So we return. Dan, what do we return then? True. Correct. So on iteration number 2, Ian, what's the value of same number? That's correct. So what's the next number, Ebrima? That's correct. So what's the next least to index number, Dan? That's correct. So what do we return, Ian? True, that's correct. So on iteration number 3, Minji, what's the same number? It's true, that's correct. And what's the next number, Adam? That's correct. So what's least to index, Ebrima? 2, correct. So what do we return, Dan? True, that's correct. So what's the value on iteration number 4, Minji? What do you think, guys? That's correct. That's correct. That's correct. Not sure if that was Ian or Dan. I sometimes struggle to differentiate your voices, but yeah, that's correct, guys. So there is no iteration number 4. That was a trap, Minji, because the least one only has 3 elements. Yeah. So that means because there is no iteration number 4, that implies that that algorithm will return true, which is correct. Because in this particular case, 3 plus 1 is the same as 1 plus 3, which is the same as 2 plus 2. Yeah? So that's correct. But now, let's break it. Let's break it. Let me present you a problem. So let's take it from there. I don't want to remove anything. Imagine that this is what we've done so far. But now, imagine that because of whatever reason, the second list has more elements than the first one. What will this algorithm return? True or false? Correct. It still returns true, which is not correct. I don't think that's correct. Yeah, because probably, I'm not sure if the exercise is explicitly. Yes, I think it is. Look at the last assertion. 9 plus 7, 16. 8 plus 8, 16. 7 plus 9, 16. However, because the second list has a fourth argument, that's literally the same problem. The algorithm should return false. So, can anybody suggest how to deal with the problem of having arrays with different number of elements? That's correct. Absolutely. That's brilliant, Adam. That's brilliant. Look, let me move things around a bit. I mean, if the elements have different size, then that's it, right? There is nothing else we can check. So, look, return list1.length equal list2.length and whatever. Yeah? Do you remember the Boolean operators we talked about on the last week? If the first expression, so if we got false and something, what will that return, guys? False and something. False, that's correct. So if the first expression on the AND operator is falsy, the next one is not even going to be evaluated because the whole expression is falsy. And what if we got on the other way around, true and something? What will that expression return? Something, that's correct, because the first expression is truthy, then the AND operator delegates the responsibility on the second expression. So that's literally what we are doing here. If both expressions have the same size, then go on. However, if the lists have different size, then stop, break it, because there is no point on continuing. Yeah, so that's the way it works. So yeah, that's correct. But now imagine that they all have the same number of elements. If I change, for instance, one of the iterations, what should this function return? True or false? It should return false, right? Because 3 plus 1 is not the same as 1 plus 13. I think that's pretty obvious. Will this function return false as expected? That's correct, guys. This is going to return true because the first iteration, true. Second iteration, false. But so let's first iteration true. Second iteration, 1 plus 13 is not the same as 3 plus 1. So that will return false. However, on the third iteration, same number is still false. Number is 2. List 2 index number is 2. So is 4 equals the original one, which is 4? Yes. So the function will return true, which is not correct. Is not correct. So how can we solve the problem? Well, we can change the expression a bit. Let me remove the reduced matrix. So we can say, hey, if on the previous iterations, yeah, all the pairs matched, then continue. Else, return false. Yeah. If at some point we broke the chain, if at some point same number became false, there is no point on the next iteration. After iteration number 2, it doesn't matter what happened on iteration number 3, 4, 5, 6, 7. Yeah. So if all the previous iterations were successful, then continue checking the current one. If not, then continue returning false. Yeah. There is a shorter way of running that piece of code. Of course, you can set if same number equal true, or you can leave it like that, yeah, because same number is truthy, so that's the same. Or you can do it in one line. Return. Look at how cool this expression is. Same number, and then whatever comes next. You see how cool this is? Again, the Boolean algebra we learned on the last week. If they are the same on the previous iteration, then return whatever you want next. If they are not the same, that will return false until the end. So let's play with this example. So iteration number 1. What is the same number value Minji? That's correct. It's true because that's our default one. So what's the first number, Adam? Oops. Sorry. Yes, I spoiled it. Sorry about that. Yes, you're right. First number is 3. Correct. So what do we get on item index, Brima? Brima, are you there? Okay, cool. Dan is 1, that's correct. Is 1 because index is 0. So item, sorry, I say item 2, that's my fault, yeah, that's a typo. Item 2 index, we are referring to the first element, yeah? So Dan, can you tell me what do we return after the first iteration? It will be true, that's correct, yeah? So iteration number 2, what's the value of same number, Ian? That's correct. So what's the next number, Minji? That's correct. It's 1. Fantastic. So what's the next item to index, Adam? That's correct. So what do we return then, Ebrima? That's correct, because 1 plus 13, which is 14, is not the same as the expected, which was 4. Yeah. So now, iteration number 3. What's the value of same number, Dan? Correct. So what's the next number, Ian? Is 2. That's correct. So what's the next item to index, Minji? That's correct. So what do we return, Adam? What do you think, guys? Why true, why false? That's correct, Ebrima. What's the value of same number? We got it here, Adam. It's false. So now we're doing false and whatever. Yeah? False and whatever. That returns false because we're using the and operator. Yeah? That's the way we can cut the rope. We can stop analyzing any further iteration. As soon as one iteration fails, the algorithm will return false forever, which is correct. That's what we want. Yeah? As soon as any of the iteration fails, then it will complete the journey. So let's see if it works. Here you go. We got confetti time. Yeah, so that works. Questions? No questions, guys? Let me have a look to what Adam did. So Adam is oh, that's interesting. So Adam is creating a new array, and so he's essentially adding all the pairs, yeah. So from the first to the second array, and then Adam, do you want to explain what you did? Okay, yeah, that's interesting. Yeah, I mean, that's absolutely fine, Adam. It's great to see different coding styles. Yeah. So once again, guys, the important thing is to find a solution, and definitely you found it. So nice one. Well done, Adam. Cool. So we have 15 minutes. So let me check what's next. I'm good palindromes. Let me skip this one because that's slightly complicated. Let me focus on question number 4, which is easier. Actually, few of you, I think 2-3 of you, managed to solve it. FYI, I'm not going to solve the 5th question. I'm not going to solve it because it talks about higher order functions. Higher order functions is essentially the topic of the board challenge of the week. I hope you've noticed this morning, earlier on 8:30, I've sent you both the beginner and intermediate challenges. Yeah, so please have a look to these challenges, and then we may refer to the 5th question once we deal with the board challenge review. So question number 4, that's a good one. It's not particularly complicated. Square digits. We got one argument, which is essentially a number. Yeah. So we want to return another number as a result of squaring every single digit on the input. So what's the result of squaring number 9, guys? 81, correct. And then the result of squaring 1 means 1 by 1 is 1, another 1 by 1 is 1, and 9 by 9, which is 81. Yeah. So that's pretty much the what we are trying to achieve. So can you give me, guys, a decent argument name? Anyone? That's controversial, and that's the reason why I asked the question. So I'm very happy you say that, Minji. Numbers in plural. I'm not convinced about that. If I'm dealing with a function and I see an argument called numbers, mentally speaking, I will imagine something like that. An array of numbers. In reality, guys, we have a single number. It could be a large one. I'm okay with that, but it's a single number. Yeah, so let's be careful with the semantics of the exercise. So essentially, number is something like that, 9119. Yeah. So I will show you my strategy. The steps I would like to follow is, first of all, convert it to a string. So that's essentially 9119. Yeah. Why I want to do that? Because once it's a string, I can split it into an array of individual digits. 9, and then 1, and then 1, and then 9. Yeah, that's pretty much it. Why I'm doing that? Because once I have an array of individual digits, then I can square each individual digit. So that will become 81, 1, 1, and 81. And why I'm doing that? Because eventually, once I get that, I can join the array into a string. So I will get 81 and a string still of 81, 11, 81. And finally, I can convert the result into a number, 81, 11, 81. Yeah, this is going to be my 5-step based strategy. So first of all, return, convert it into a string. How do you convert, guys, a number into a string? That's correct, Meiji. To string. Fantastic. Yeah. So step number 1 is covered. And now, how do you split it into an array of individual digits? What else? Quotation mark, empty string, right? That's correct. So split empty string will transform 9119 into 9,1,1,9. So then the third step, square each individual digit. How, guys, do we transform an array into another array of the same size? Which method? That's correct, Ian. Map. And then map, here we get a number, so we can return number multiplied by number. Absolutely, my friend. Absolutely, my friend. You should be very careful when dealing with this type of operations, yeah? Because a split empty string is creating an array of strings, as Adam said. So in reality here, what we are doing is 9 multiplied by 9. Even though sometimes JavaScript is smart enough to deal with these oddities, I will strongly suggest you to transform the array of strings into an array of numbers. So different ways we can do that. Well, first of all, guys, let me rename the argument from number to string number for readability purposes, then, because I'm making a bold statement that I'm playing with strings. Yeah. So how do you transform, guys, a string into a number? There are two ways. First of all, the long way. You can do that. That's okay. However, Minji was suggesting something very interesting. There is a shorter way, guys, of transforming a string into a number, which is doing that. Look at how cool this is, JavaScript. Yeah? Plus a string number will transform 9 into 9. Yeah? Another way of solving the problem will be using map. We'll be doing something like that. Yeah. So pros and cons. Well, if you transform first of all every string number into a number, then you are playing with pure numbers. Yeah. However, you are adding a new iteration. So if you got many numbers, yeah, that will be costly because we need to iterate again and again just to transform from string numbers to numbers. However, if we don't do that, the problem is we have to transform each number twice, yeah, following this pattern. So I don't think there is any perfect solution. Yeah, of course we could, yeah, definitely we could do something a bit more complicated. Let me go back to the code. So if I don't want to iterate again, if I don't want to convert twice, so I could create a new variable, number equal plus string number. I could do something like that, and then I could return number multiplied by number. So that will probably be the most efficient solution, because I wouldn't need to loop through all the elements just to convert them individually from strings to numbers, and then I could avoid converting strings to numbers twice for each element on the array. Yeah, but yeah, I don't want to be that efficient. I know I'm playing with a small list of numbers, so let's leave it like that. And one more thing. I'm not a big fan of calling it string number because that's confusing, right? So number, you got number here. So why we call it number again there? That's a bit confusing. So personally, I prefer to call them string digit. Like that. Yeah, because I have individual digits. Yeah. That's the way I can easily differentiate from a long number 91119 into individual digits 9, 1, 2, 3, 4, and so on. Any question, guys? Hello? Cool, fantastic. Thank you, Ian. Thank you, Minji. All right, so now you should be able to complete the last remaining steps. So how do you join all the elements of an array? Actually, this is an array of numbers. It's not an array of strings anymore. How do we join them into a single token? How do we do that? Dot join. And what else, Minji? Empty quotation mark, correct, yeah? So you see, we are reverting the process. First of all, we spread all the numbers into an array, and then we gather them into a single string. Because remember, guys, join returns a string, yeah, always. Even if you got an array of digits or an array of numbers, join always returns a string. So if we run that piece of code, it won't work. It won't work because the result is expected to be a string. Sorry, a number instead of a string. So last step, how do you convert the result, a string with 8111 whatever, into a proper number? How do we do that? Correct. Yeah. Yeah, you're right, Adam. Look, after step number 3, you have an array of numbers. You're right. However, as I said, every time you do join, it transforms everything back to a string. That's the point. So we need to deal with the transformation again. And someone was advising to do that, yeah, which is correct. If I run this, that should work. Here you go, we got confetti time. Or can anyone tell me the shortcut? Plus, fantastic. You don't even need the parentheses, guys. You don't even need the parentheses because that will run at the end of the expression. Look, boom, it works. Let me share the snippet on Slack. Any questions, guys? No? Cool, thank you, Adam. Let me quickly go through your review. So question number 4. Ooh, look. So Ian, he's essentially, first of all, creating an array of strings, and then he's multiplying them, and then he's joining them. It's essentially the same algorithm, yeah? I struggle a bit to read it, and Ian, just remember to add, for instance, the semicolon at the end. Also, as I mentioned before, not sure if I'm a big fan of calling num, because then, I don't know, that's maybe something personal. But on top of that, what is not personal, what is strict is, remember num, what type of data num is, Ian? That's wrong, it's not a number. Num, yeah, it's a string, correct, it's a string. So even though it works, because as I said before, JavaScript is smart enough dealing with these basic math operations, but I think from a readability point of view, we should be careful. Yeah, but yeah, all good, fantastic. Yeah, all good. Then the last one solving the problem was Ebrima. So Ebrima, yeah. So few notes for Ebrima. First of all, he is referring to the argument as string. That's extremely annoying, Ebrima. Extremely annoying, because the argument is not a string. The argument is a number. Yeah, so you're just making that up. And then, okay, even though it's a number, you call it a string, and then what you do is you use the backticks. That's a different way to transform to strings. Okay. And then you split it. So that's the same thing as Ian did. So you got an array of strings. Then you map. That means you create an array of an array of numbers, even though number is now a string, and finally you join. Yeah. So yeah, I like it. It's a different way of dealing with the same problem. Yes, guys, please let's look after the semantics and the readability of the exercise, despite of the eventual result. Cool. I think we are out of time, so I would like to leave it here. I'm not going to solve the 5th question. I'm not going to solve the second one, the palindromes one, neither, or the third one. I don't remember which one was that, because that was way more complicated. So I will leave it for a future session. Anything else? Cool. Fantastic. Thank you very much, guys. Thanks for watching. Bye bye.